everyone. I am Harshita and this is Nikhil, and we are presenting our Samsung Capstone project, AI-based food recognition for visually impaired. So, AI-based food recognition for visually impaired is a project that mainly focuses on people who have a very low eyesight or they cannot exactly differentiate what is in front of them. And we are recognizing the food that is kept in front of them so that they can hear what they're eating. The main objective is to provide real-time audio descriptions of food items and empowering visually challenged individuals to make informed choices about their needs without relying on their sight. So the challenges faced by visually impaired individuals. So visually impaired is nothing but either they cannot see properly or they have some kind of disorder, and they have a very low eyesight, and they need like manual assistance, like people next to them, they have to tell them what they're eating, or they need specialized devices that are usually expensive. So to cut their cost and their time, we have developed a technology that recognizes the food. So what is food recognition technology? So we are implementing artificial intelligence that focuses on identification and categorization of food items which are presented in different types of classes. Each class is a different food item, and the technology leverages advanced machine learning algorithms and neural networks to analyze visual data and classify the depicted food items. Our problem statement is nothing but visually impaired people, they need some technology to assist them on the food that they are eating, and we are creating a technology that provides real-time feedback and it remains cost-effective. The libraries that we are using are NumPy, which is for numerical computing in Python, and TensorFlow, which has various machine learning and deep learning tasks. Matplotlib is used to visualize the data that we are using and creating static, animated and interactive visualizations. Streamlit is mainly used for creating web applications, and below we are using Python image library that allows us to open, manipulate and save image files. GTDS is nothing but Google's text-to-speech API that we are using for the text-to-speech audio-based recognition.
The dataset we got from a Kaggle, which we have used in this. It's a 101 dataset which contains images of 101 class labeled images. Basically, we have designed a CNN architecture custom model. It takes a lot of time for training for 101 classes. So that's why we are trained for around 10 to 15 classes for some extent. And the visualization and the system relies on specialized libraries and APIs to access the images and all. It reflects on latest and relevant data and data images which are there in the dataset. The dataset, understanding of dataset is as follows. It contains images, metadata and food classes. Basically, images, the various classes of food are grouped in the images section, in which the images are labeled in the data, while metadata contains supplementary information associated with each image associated with in the data set. The key is the metadata in the data set, whereas food classes specify 101 food classes which are present inside the belongs to it, labeling essential for training and as well as testing. And then the training of data, testing data and class distribution, these are the we have to do on the data set while implementing. The training data subset dedicated training machine models. It includes sustainable portion of data, images paired with it and corresponding food classes. Test data, a subset of reverse evaluating trained models. It contains images for model testing and all. Class distribution, the classes of images must be distributed in comprehensive manner so that it can easily identify whether which image belongs to the type of classes. And then we have used convolution neural network architecture for designing this model. This basically contains convolution layers as well as pooling layers and fully connected layers. Convolution layer is basically, it has a filters over the data input images, and then pooling layers will reduce the spatial dimension, whereas fully connected layer make predictions based on the extracted features from these layers and all. And then this is the convolution. A core operation of CNN in convolution involves sliding a small filter over the input data to detect the features in the image. Whereas pooling after convolution, pooling layers are often used to reduce the spatial dimension. While retraining model is important, max pooling is also a common pooling technique which we have used, and also fully connected layers after several layers of convolution, pooling the final features are mapped and the predictions of data has done in this. And the advantage for this system is enhanced independence, so that every challenge people can make a zone without mutual assistance. You can independently you can recognize the food based on the audio, recognize food and converts the text into audio. You can improve dietary management with the food recognizing various diets you can manage with it. Health and safety by taking visually their healthy risks and identifying allergies and all. By this, you can using this system, you can recognize the food. In conclusion, the food recognition technology plays a vital role in enhancing independence and quality of life for visually challenged individuals. The innovation solutions in utilizing image recognition is a very plays a vital role for sensor technologies and all. Essential information about consuming food recognizes on it. Then
We'll share the code. We had used Inception V3 model, which was a pre-trained model, but then sir advised us not to do that, and he advised us to create our own model. So we used CNN architecture to create our own model, which is a sequential model. Sequential is nothing but the layers are added on top of each other in a sequential manner. We are using Keras, which is an API which contains a lot of modules, and the modules that we are using from Keras layers is dense, convolutional 2D, max scoring 2D, flattened, and dropout. So convolutional 2D, as Nikhil explained, it basically has a filter which goes through each and every layer to find important information or unique patterns in the layers. And we have the number of filters in convolutional 2D that we are using are 32 filters, and the kernel size is 3 into 3. Max pooling 2D we are using, we are adding that, and we are flattening it here. Flattening is basically used to flatten and connect all the layers in the model, and we are using activation RELU, and then we are compiling the model and we are saving it here so that we can load the model later on. And here we are loading the model that we have saved in our drive. So we can drag and drop a file here, which is an image of a foot. We can choose any of these images. We're uploading that image. So this is an ice cream and it has predicted it as ice cream.
It's ice_cream.
Yeah, it is ice cream. The class name is ice_cream, and so it is ice cream. Or we can also use French fries. So it predicts it as French fries.
It's a French_fries.